Predicting future data requires understanding both the expected trend and the risk involved. Real-world sequences often have noise levels that change over time. Most current models assume this noise stays constant, which is a significant error. This mistake leads to models that overfit noisy outliers instead of learning the signal. LSGVAE is a new framework that separates the trend from the volatility for better predictions. Figure 1 shows why standard models fail. Panel A assumes constant variance. Because the training objective treats all errors equally, the mean prediction follows temporary spikes. In Panel B, LSGVAE uses time-varying variance. It recognizes unreliable data and widens the confidence interval. This prevents the mean predictor from chasing noise, staying focused on the true underlying trend. Figure 2 outlines the 4 main stages of the system. First, data is normalized and cut into patches to preserve local patterns. Second, an encoder maps these into a latent space to represent uncertainty. Third, a global transformation predicts future states in a single step, avoiding slow recursive steps. Finally, a dual-head decoder splits the output. One head calculates the trend, while the other estimates noise levels. The methodology involves cutting the input into patches to help the model see local trends. These patches pass through a variational encoder to create a representation of the data uncertainty. A latent dynamics module then predicts the future state in one parallel pass. The dual-head decoder then reconstructs the data. The first head focuses on the mean value, and the second head estimates the variance using a soft plus function. Figure 4 compares LSGVAE against other models on the ETH1 dataset. Competitors like Coupa and PatchTST produce wide, static uncertainty bands. These bands are uninformative because they do not change as data becomes more or less predictable. LSGVAE provides confidence intervals that grow and shrink to match the actual volatility of the series. This provides a clearer picture of risks and the reliability of the forecast at any given time. LSGBA sets a new standard for accuracy and risk modeling. By accounting for changing noise, the model creates a more accurate mean predictor. It is much more efficient than diffusion models because it generates the full forecast in one step. Tests across 9 datasets show it performs well in many different scenarios. The concept is versatile and can be added to existing GEN or VAE models to improve their uncertainty calibration.